Hi friends, welcome to my channel. Let's have a look at a classic problem, problem 129, some root-to-leaf numbers. In this video, we're going to share a solution based on binary tree traversal. First, I'll read through the problem statement to digest the requirement, and then we do a simple analysis, and finally share the code. First, let's look at the statement. So we are given the root of a binary tree containing digits from 0 to 9 only. Each root-to-leaf path in the tree represents a number. For example, root-to-leaf path 1 to 3 represents the number 123. So we are required to return the total sum of all root-to-leaf numbers. So here a leaf node is a node with no children. So let's look at the two examples here. So in the first example, the two root-to-leaf numbers are 12 and 13, so the total is 25. In the second example, there are 3 leaves, therefore there are 3 root-to-leaf numbers. So one is 495, one is 491, and the other is 40. So together we get 1026. So that's the second example. So before we look at the analysis, let's also look at the constraints or additional assumptions for this problem. First, the number of nodes in the tree is in the range given by the closed interval, with two ends being 1 and 1000. So the first bound tells us this tree is not null, and the second bound tells us the problem size. And the second constraint is that the node value is in between 0 and 9, in other words, single digit. So the depth of the tree will not exceed 10, right? So this actually restricts the range of the root-to-leaf numbers. So with that said, let's look at the analysis. So this problem actually can be solved by a number of methods. So here we are going to use a solution given by binary tree traversal. So here we are going to use an iterative format of depth first search to demonstrate the idea. So in the stack to aid depth first search, we are going to store for a node 2 pieces of information. So one is the node itself, and the other is the root to the node number, where the root to node number is the decimal number represented by the root to node path. For example, if we have a root to node path 4 to 9, then for node 9, we are going to store the node 9 itself and the corresponding decimal number, that is 49. So when we look at the child, we can easily get the corresponding information, or especially the path to node number. For example, in example 2, let's consider the left child of 9, that is 5, right? For this node, we're going to store node 5 itself, also the number corresponding to this node 5, that is 495. Because we go to next layer from the root 9, so the decimal number represented by the root to the node 5 is amplified by 10, right? So we multiply by 10. So let's here we write 210, so just delete 1. So root to 5 number times 10, then plus the node value at 5, that is 5. So we get node 5 and 495. So in the process, if a node is a leaf, then we are going to add the corresponding number to the final result. So that's the whole idea, and also the corresponding process. So with that said, I guess writing the code for this problem is rather straightforward. So now let's look at the code. So here I'm going to write a nested function. So first I'm going to initialize a result variable. So this result variable will hold the sum of all the root to leaf numbers. So for this, I'm going to write a inner function called traversal. So this traversal, we're going to traverse the tree and locate the root to leaf numbers and add the contribution to the result. For this reason, I'm going to make the result variable non-local, right? So non-local result, so that we can update the result state during the process of traversal. So with that said, let's first consider a special case or stop condition. That is, if not root, then we are going to return or stop. And then we are going to do a iterative depth first search. So for this, I'm going to use the stack data structure. So we're going to store the root and the corresponding decimal number from the root and ending at the current node. If it's root self, so the value is nothing but root value. And then we're going to do the while loop, while stack. First, we're going to get the node and the pass to node number. So that is node and value or number. That is stack pop. So first, we're going to check if the current node is a leaf or not. If it were a leaf, so we would like to add the corresponding value to the result. So if not node, so here I will write node left and not node right. So in this case, we're going to increment the result by the value. So next, we're going to check the left subtree and the right subtree to see if it's not null. If it's not null, we're going to put the corresponding information to the stack. So if node left, so in this case, so we're going to do stack append. So the information is node left, and then we're going to multiply the previous value by 10, then plus the node left value. So this is for going to the left subtree. So now let's consider the right subtree. So in this case, so we're going to append node right, and then the value times 10 plus node right value, right? So that's it. So once we finished the traversal, actually we added all the root to leaf numbers to the result. So what we are going to do is that we call this traverse function. So this traverse function has the effect of updating this variable result, and then we are going to return the final state of this result variable. So with that done, so I guess this forms a format of solution to this problem. Let's do a special case check first. Yeah, it passes the second example. Now let's look at the generic case. Yeah, that passes all the cases. So I guess that's about it for this specific problem. As we mentioned at the very beginning, there are many ways or formats to solve this problem. Here is just giving a solution to demonstrate the process of traversal and adding the contribution of all the root to leaf numbers. So you're welcome to tune this code and come up with other formats. With that said, I guess that's it. Thank you.